In the post-war aviation boom of the 1950s, airlines sought faster, more efficient aircraft to replace their aging fleets. Lockheed's response was a revolutionary L-188 Electra, a turboprop airliner that promised jet-age speed with propeller economy. Work on the Electra began in 1954 under the internal project designation Model 188. Collaborating closely with major airlines, Lockheed engineered an aircraft that could handle frequent short-haul trips with unprecedented speed and reliability. The story begins in the early 1950s. Jet technology was advancing, but turboprop engines offered an exciting middle ground. Faster than traditional piston engines, yet more economical than jets. Airlines needed a solution to bridge this technological gap. Lockheed, known for military giants like the P-38 Lightning and the Constellation, set its sights on the skies of commercial aviation. They envisioned a sleek, powerful aircraft that would revolutionize short to medium-haul travel. The project was ambitious. Designated Model 188, internally, it would later be christened Electra, a name already familiar to Lockheed fans from the pre-war Model 10 Electra. In 1954, Lockheed officially announced the Electra project. It promised seating for up to 98 passengers, a pressurized cabin, and the use of revolutionary Allison 501 D13 turboprop engines. The first prototype took the skies on December 6, 1957. Pilots marveled at its smooth power delivery, remarkable efficiency, and the reassuring hum of its 4 turboprop engines. Lockheed engineers knew they had something special, but they also knew the real test lay ahead, earning the trust of airlines and the public. Airlines quickly lined up to order the Electra. American Airlines, Eastern Airlines, brand of KLM, the list grew quickly. The Electra offered speed, cruising at 350 miles per hour, and luxury, wide seats, full meals, and a smooth ride compared to piston engine aircraft. For a time, it seemed the Electra could do no wrong. It connected cities, families, and dreams across continents. It was, for a moment, the future of air travel. In 1959 and 1960, tragedy struck. 2 Electra aircraft suffered catastrophic mid-air breakups. Brana Flight 542 over Texas and Northwest Orient Flight 710 over Indiana. The aviation world was stunned. Investigators raced against time to find the cause. Public confidence in the Electra plummeted. The culprit was identified, a phenomenon called whirl mode, a previously unknown vibration pattern that could cause engine mounts and wings to fail catastrophically. Lockheed sprang into action, reinforcing the Electra's wings with a major retrofit program dubbed the Lockheed Electra Improvement Program. Every aircraft was strengthened, every engine mount inspected, every risk addressed. The fixes worked. No Electra ever suffered a structural failure again, but the damage to its reputation had been done. Still, for those who flew it, pilots and passengers alike, the Electra remained a beloved workhorse. Even as jetliners like the Boeing 707 captured the world imagination, the Electra found a second life. Air cargo companies, military forces, and regional airlines all found new uses for the rugged, reliable airframe. Electras flew cargo routes, carried humanitarian aid, and supported military missions across the globe. Today, very few Electras remain in service, but their DNA lives on, most famously in the military P-3 Orion, a direct descendant of the Electra that continues to patrol oceans around the world. The lessons learned from the Electra's early tragedies helped shape aircraft engineering forever, leading to safer skies for generations. The Lockheed L-188 Electra was not perfect, but it was bold, innovative, daring, It taught us that in aviation, as in life, progress comes at a price, but also with extraordinary rewards. The Electra's hum may have quieted, but its spirit will always soar. At the heart of the Electra were its four Allison 501 D13 turboprop engines, derived from the T-56 military engine family. These power plants were both robust and efficient. Each engine turned a massive four-blade propeller, creating thrust not only by moving air backwards, but by the powerful torque of spinning blades, a key difference from pure jet thrust. Lockheed engineers spent thousands of hours in wind tunnels to perfect the Electra's aerodynamic profile. Designed to cruise at altitudes up to 25,000 feet, the Electra could reach speeds of up to 405 miles per hour at optimum altitude, with a typical cruising speed around 350 miles per hour. The Electra's fuselage was constructed using advanced aluminum alloys, featuring a semi-monocoque designed for maximum strength with minimal weight. Its pressurized cabin allowed passengers to fly in comfort at high altitudes, reducing fatigue and noise compared to older piston engine planes. Passengers aboard Electra enjoyed unprecedented comfort for time. Flight attendants, known then as stewardesses, served meals on real china plates, and drinks were poured into crystal glasses. Fly was not just about getting there, it was an experience.